In section 2.7, we're going to take a look at inverses and the inverse functions. The first thing to take a look at is the criteria for functions to be inverses of each other. It says here if f of g of x is equal to x and g of f of x is equal to x, then f and g are inverses of each other. We can also write g in this notation as a result, with f, which looks like a little exponent of -1 up above it. That's meant to stand for f inverse, so the inverse function for f. The domain of this thing called f inverse is the range of f, and the range of f inverse is the domain of f. I'm going to use this to verify these two functions here for f and g are inverses of each other. So by what the thing says for two functions to be inverses, if I start out with f of g of x and check what happens with that, that would look like the function f of x, which is 3x plus 2, but we're going to be putting g of x on the inside. So that would look like 3 times x minus 2 over 3 plus 2. The 3's here, well, we could cross those out, and it would just be x minus 2 plus 2. And the 2 and -2, those would also go away, and all that's left over is x. We have to do it the other way around, though, to fully check if they're inverses. So we have to find g of f of x. Now we're starting with the g of x function. So wherever x is on top, we're going to be putting f of x. So that would look here like 3x plus 2 minus 2 over 3. And the 2's will go ahead and cross out. 3x over 3. And the 3's will also cross out. So this one also turns out to just be x. And so since they're both x, we can say that g is an inverse of f, or vice versa. And so since it's the inverse function, we can denote g as this in notation as f inverse. What we're going to do now is look at how we can take a function and create its inverse function. And there's a step-by-step process outlined here that we're going to go through in these following examples to see how to solve for the inverse. Okay, the first thing we need to do when trying to solve for the inverse is to write our function f of x as y equals. So we're going to replace f of x with y. So in this case, I would change it to y equals 7x plus 5. The second thing to do when trying to solve for the inverse, is kind of the key step to make the inverse happen, is to swap the x and the y. So we'll change it into x equals 7y minus 5. Now that we've swapped the x and y around, it's no longer solved for y anymore. We have to go back through the steps to solve for y. So in this case, what I'll do is I'll add this 5 over. So that'll change this into 7y equals x plus 5. Divide out the 7. And as a result, we'll have y is equal to x plus 5 over 7. So the last step is to write y back in a function notation, but now using the inverse function notation for f inverse of x. So we'll say that f inverse of x is equal to x plus 5 all over 7. For this one, f of x equals 4x cubed minus 1. I'm going to follow the same set of steps from the last one. First thing to do is to write y equals 4x cubed minus 1. Then step 2 is to swap x and y, so it'll be 4y cubed minus 1. After we swap the x and y, then we need to solve this again for y. So now we'll add them 1 over, and then it'll change it to 4y cubed equals x plus 1. Then you can divide 4 from both sides, and it'll turn into y cubed equals x plus 1 all over 4. Now, since this is y cubed and we want to solve it down to just y, I'm going to take the cube root of both sides. The cube root will get rid of the third power together to leave it as just y equal to the cube root of x plus 1 all over 4. So our final answer would be to write that as the inverse. F inverse of x is equal to the cube root of x plus 1 all over 4. Okay, on this one, f of x equals 5 over x plus 4. So I'll go ahead and rewrite it as y equals 5 over x plus 4. To solve for the inverse, we'll swap x and y. X equals 5 over y plus 4. So now that I've swapped the x and y, I've got to solve back out for y. So we're going to subtract the 4 over from both sides, change it to x minus 4 equals 5 over y. Now, since we're trying to solve for y, and we have a y in the denominator, to get rid of the fraction, I'm going to multiply both sides by y. That way I can cross the y out, and this will look like y x minus 4 equals 5. Now, in order to solve for y, at this point I'd like to divide both sides by the x minus 4. And if I divide both sides by x minus 4, that'll leave just the y, and that'll be equal to 5 over x minus 4. So that'll be our inverse function here. F inverse of x equals 5 over x minus 4. On this one, f of x is equal to 2x minus 3 over x plus 1. So first things first, let's write as y equals. Trying to find the inverse, so we need to swap x and y. So now the x will turn into the y. All the x's will turn into y, so it'll be 2y minus 3 over y plus 1. So it's a little bit more complicated. So how we're going to solve it from here is multiply both sides by y plus 1. Multiplying this by y plus 1 because that's in the denominator, and I want to cross that out from the one side. So here this will change it to be x times y plus 1 equals 2y minus 3. And we're always trying at this point to try to solve for y. What I'll need to do next is to distribute that x into the parentheses. What that would result in is an xy plus x equals 2y minus 3. Now at this point, in order to solve for y, we've got some of the y's on one side and some of the y's on the other side. So we need to get all the y terms together in order to solve. So I'm going to do that here. First off, I'm going to subtract this 2y over. So it'll be xy minus 2y plus x equals negative 3. Since I'd like to get y by itself, I'm going to go ahead and move this x over. So we'll have x minus 2y equals minus x minus 3. Okay, now at this point, the only thing left on the left side are terms that have a y in common. So what we're going to be able to do then is factor out the y from each of those terms. And it would be y times x minus 2 equals negative x minus 3. And now we're just one step away from solving for y. we need to divide both sides by x minus 2. That way I can cross this out, and it'll be y equals negative x minus 3 over x minus 2. And that's going to tell us what the f inverse of x will equal to as the inverse function of f. One thing about inverses is not every function has an inverse. There's a particular characteristic that a function must have in order for it to be able to solve to get its inverse function, and that is it has to be a one-to-one function. A one-to-one function is a function in which if x1 is not equal to x2, then f of x1 is not equal to f of x2. And so only one-to-one functions have inverses. The way we're going to check to see if a function is one-to-one is by using something called the horizontal line test. If we're looking at the graph, and if we draw a horizontal line through it, and if no horizontal line intersects a graph more than once, then the graphed function is one-to-one and has an inverse. So, looking at this first graph, if I draw a horizontal line through it, it's going to cross in two places. So since it crosses more than once, this graphed function is not one-to-one and does not have an inverse. On the other hand, this other function, you can draw lots of horizontal lines through it, and they'll always cross at just one location. So that one does pass the horizontal line test, is one-to-one, and does have an inverse. On these next two, the first one, we can see with the horizontal line test that it's not going to work. So that one is not one-to-one and does not have an inverse, since the horizontal line crosses more than one time. The last one, any horizontal line will only cross at one point, so that one is one-to-one and does have an inverse. Now graphs, once we know that a function has an inverse, it's one-to-one and passes the horizontal line test, we can take a graph of the inverse function. And the graph of the inverse function, f inverse, is the graph of f reflected about the line y equals x. And so we're going to look at a few examples here of graphing the inverse function. So here's how we can take the points, if we have a few on the graph, and find the graph of the inverse. We can actually swap the x and y in each point, and that would tell us the points of the inverse function. So in this graph, we have points like 0, 1, 1, 2, and 2, 4. If I was to swap those points around in this particular graph, I would have points like 1, 0, 2, 1, and 4, 2. So I'll plot those points here. Something else it mentions in the slides is that it's a reflection about the line y equals x. So they're referring to this line here that runs diagonally. And so the graph would reflect over that and into these points that we see here and do something like this. So if this was the graph of y equals f of x, then this one would be the graph of y equals f inverse of x. On this graph, we have points like 0, -4, 3, 2, and 4, 4. Swapping the x and y in each of these, we'd have points like -4, 0, 2, 3, and, well, 4, 4 would still be the same either way. So our inverse graph would have points at those locations. And so essentially it'll just form another straight line that looks like this. Again, reflected about the diagonal line running through like so.